While there are many different ways to connect transistors into a circuit, similar to our experiences with field effect transistors, there are three common configurations of BJT amplifiers that have proven useful. In each of these cases, one of the terminals is connected to ground and serves as a reference or a common node for both the input and the output voltages. So for example, in this configuration here that's known as a common emitter, the emitter is grounded and both the input voltage Vin and the output voltage Vout are referenced to the grounded emitter. In this configuration here, both the input voltage and the output voltage Vout are referenced to the grounded base. So the input voltage referenced to ground and the output voltage referenced to ground, with the base grounded, gives us then the common base configuration. And finally over here we've got the common collector, where both the input voltage Vin and the output voltage, taken from, in this case, from the emitter to ground up here, both of them are referenced to the grounded collector. Each of these three configurations is very much similar to those that we saw in the field effect transistors. The common emitter is similar to the common source amplifier. The common base is similar to the common gate amplifier that we saw in field effect transistors. And the common collector is similar to the common drain amplifier with field effect transistors. With the input and output voltages defined for each of these different amplifier configurations, we can describe each of these in terms of the input and output voltage, the resistance seen looking into the input terminal, and the Thevenin equivalent resistance that we experience, or that is experienced at the output terminal, and then also the open circuit voltage gain AV0. So this then brings rise to this generalized amplifier circuit that allows us to characterize any one of those three different amplifier configurations in terms of an input and output voltage, an input resistance Rin, which is defined as the ratio of the input voltage, the voltage that's actually applied to the input of the amplifier, divided by the current that flows into the amplifier. It's open circuit voltage gain, A sub V0, which is defined as the output voltage, or the ratio of the output voltage to the input voltage when no load is connected. And then finally, an output resistance Rout, that's defined as the ratio of a voltage and current applied to the output when no signal is applied to the input. So as we've seen with Thevenin equivalency, we can determine the Thevenin equivalency, at least conceptually, by deactivating the source and then applying either a voltage or current there, and then forming the output resistance Rout, or the Thevenin resistance, being the voltage that is measured, or that results when applying a current, or let's just go ahead and write it, V sub x over I sub x, or applying a voltage here and then a current flows into it. And again, the Thevenin resistance, or the output resistance, is the ratio of the voltage to the current. So the output resistance is really just the resistance that we experience, or that is experienced, the Thevenin resistance that's experienced when a load is connected, and that resistance then, internal resistance, accounts for the voltage drop that occurs when a load resistor is connected. So these input and output resistances can be either as in the case here, the resistance seen by a source going into the amplifier. The output resistance is the resistance seen by a load at the output of the amplifier, and the open circuit gain is the dependent voltage source that attributes, or that represents, models the linkage between the output voltage and the input voltage. Now this load resistance here may very well be the input resistance to another stage of the amplifier, just as this signal resistance here may very well be the output resistance of an amplifier stage that precedes this. So again, this is simply meant to, in general, model the various aspects of amplification, which includes these three concepts: resistance, the input resistance, the output resistance, and the gain in a generic way. And in the next few videos, we will then be looking at how we can characterize each of those three common amplifier configurations: the common emitter, the common base, and the common collector or amplifier, in terms of these amplifier parameters.